Okay, so I'm back, and as promised, I finished off those two electrolytic cells for you to take a look at. So if you've got your workout, you can pause the video and check compared to mine, or just listen along as I race through things. So in our voltaic cell, we had inert platinum electrodes, copper 2 plus, SO4 2 minus, and water. So going through the table of relative strengths, we find that copper 2 plus is our strongest oxidizing agent. Water is our strongest reducing agent. That's definitely non-spontaneous. Keep track of those cell potentials because we'll need them. Okay, so copper 2 plus, strongest oxidizing agent, always the cathode, strongest reducing agent, the anode. So I've taken the half reactions. 2 electrons gained, 4 lost, multiply the top one by 2. We get our balanced redox reaction. Overall cell potential, cathode minus anode, is negative 0.89 volts. It's negative, so non-spontaneous. It says, how many volts do you need to apply to get the cell to work? Anything greater than positive 0.89 volts, and the cell will work. Anything less than that, and it just sits there, non-spontaneous. Diagnostic tests, you could test all 3 products. Number 1, the copper, you would see a red-brown solid. Number 2, the hydrogen ions, the pH will decrease. As hydrogen ions increase, it becomes more acidic. Or collect the gas and see if a glowing splint relights for the presence of O2. Drawing the cell again, we just keep it simple. It's a little container, a beaker with copper sulfate aqueous, our 2 inert electrodes, a negative cathode, a positive anode, electrons going towards the cathode, and a power supply. That's it. Okay, so last one. This is an electrolytic cell with lead electrodes on both and an aqueous solution of cobalt 2 chloride. And so when you go to the table of relative strengths, we've got lead, cobalt, chloride, and water. You will discover that cobalt 2 plus is the strongest oxidizing agent. Lead is the strongest reducing agent. Again, it's non-spontaneous. We keep track of the cell potentials. We'll need those. Okay, so there's our half reactions. Electrons are balanced, so we just add this one up. Super easy for the overall cell reaction. Calculate the cell potential, cathode minus anode. We get negative 0.15 volts. So greater than 0.15 volts makes this cell work. It doesn't ask for diagnostic tests. Draw and label a simple cell. We've got our 2 lead electrodes. Just pick one and call it the cathode, which gets the negative sign. The other one is the anode, which gets the positive sign. Electrons going towards the cathode from a plus-minus power supply in cobalt chloride aqueous solution. And we are done. My hair's starting to look like here with this pandemic. My wife keeps threatening to cut it, and I'm a little scared, but I guess I don't have much to lose. The only people who are going to see it are 120 of my students, right? I'm sure you guys will be fine with that. Okay, and I have lost the assignment. How about that? Okay, wow, lucky you guys. So the assignment for you is in your study guide. And I would like you to work on, there was 2 pages originally, but I've shortened it to 1 because one of them doesn't make sense. Here we go, page 275. And there are only 2 of them to do. I just realized I did page 275. I did both of those for you, you lucky rascals. So, my apologies. It's page 274, number 3 and 4. Page 274, numbers 3 and 4. And that should only take you about 15 to 20 minutes. Yay. That's not too bad. And I've got the answer keys online in Google Classroom for you. That worksheet is called Electrolytic Cells, Extra Exercises. You cannot do 1 and 2 yet. We're going to learn how to do those tomorrow. Okay. Hope you guys have a great day, and take care. Be safe.